In the next, sometimes we are expected to go for such calculations also. The lead sulphide is isostructural with NaCl. The shortest distance between the Pb plus 2 and S minus 2 INC is given. With the help of this shortest distance, we are expected to give the volume of the unit cell. So, there two things are to be taken care of. One, what is isostructural pattern and what is the structure of NaCl. Isostructural means it is the two different crystalline samples having the same arrangement of the particles in the crystal lattice are called as isostructurals. So, the structure wise PbS and NaCl have the same pattern. And what about the NaCl structure? For the NaCl structure, which is a face centered type, we have the edge carrying alternate arrangements of Na plus and Cl minus, and that we put this way. At the center, if we have the smaller positive ion Na plus, on either sides it will be the larger Cl minus, and the center of these spheres, the extreme spheres Cl minus, that becomes an edge. So, if this is the edge for NaCl, the same will be the edge for PbS also. The supplied information is the shortest distance between the Pb plus 2 and S minus 2. That means the positive and negative ions. It is the positive ion at the center and the negative ion on either sides. The shortest distance, we get it here. And this shortest distance is 297 picometer in lead sulphide between the Pb plus 2 and S minus 2. And with this distance, can we get the edge? Very simple. It is half of the edge length because it is only the two radii making up 297 picometer, and the entire edge, if it is to be taken, we just have to double this value, 297 picometer. And I don't want to do it with precision because for me the time is important and I look at the options. Options have bigger margin of difference. Therefore, with the approximation, I continue. 397 is approximated to 300 picometer, and I know 1 picometer equal to 10 raised to minus 10 centimeter, and that is the unit in which the answer has to be given. Therefore, it is 300 into 10 raised to minus 10 centimeter, or I can put it as 3 into 10 raised to minus 8 centimeter. This is half. And about the entire edge, I double it. Therefore, edge, that is A, equal to 6 into 10 raised to minus 8 centimeter. It is the edge. And what is the volume? A cube will be the volume, and this is equal to 6 into 10 raised to minus 8 whole raised to 3. And I know 6 raised to 3 is 216. So it is 216 into 10 raised to minus 24 centimeter cube. The closest of 216 is number 1, 209.6 into 10 raised to minus 24 centimeter cube. Therefore, I go for option A, 209 into 209.6 into 10 raised to minus 24 centimeter cube. That way. See here how these are working out. They require the time which is just enough, about 40 to 50 seconds. Like half of the edge length, approximated value, double it, edge length, then go for the volume. Immediately it will be giving the answer in simple calculations. Are you clear? In solids, we have another variety of the question where the diagram is given or the figure is given for some kind of a unit cells and from which some informations are asked. This is the one we have. A compound MPXQ. It has the crystal lattice with a particular unit cell, and that unit cell is shown. Type of the unit cell or type of the lattice is cubic close packing, where it is the cubic close packing of X. The formula of the compound is to be derived from this figure and from the information supplied. Look, information is not more than the type of packing. It is the CCP, it is the cubic close packing, and that cubic close packing is developed by X. So, how we are to place this X in that unit cell? Two things. CCP, that is the cubic close packing, has the face centered unit cell, and this face centered unit cell should have the corner points in the form of that particle which is going to develop this packing. It is the packing made out of X, therefore, this X should hold the corners. That is why we are having the corner particles X. And another, it is to be M, and M is to be accorded in the alternate positions. In this, the formula is to be derived. Now look, to get the formula and to get the proportion of the M and X, we can do it in a very simple manner. Identify the lattice points and identify their number. Going for the M, the lattice points, that is the cross marks, these lattice points are seen at the edge centers and also seen at the center of the unit cell. Thereby, if we are to see their number, we get 4 in the lower plane, 4 in the upper plane, and 5 in the middle plane. Totally, it is 13. And for the X, it will be 5 in the lower plane and 5 more in the upper plane and 4 in the middle plane, and it comes to 14. And out of the 13 M, look, out of the 13 M, 1 is at the center. And this is the central particle, and its number is 1. It is not going to be fractionalized. But the remaining 12 are at the edge centers. Therefore, it is the 12 particles or 12 lattice points at the edge centers and each edge center will give the contribution of 1 by 4, and this gives 3 particles out of it, and one from exactly the center of this unit cell, and that gives the particles 4. Then for coming to X, we see it at the corners, 8 corners, and at the face center, 6 face centers. In this case, I count the number of particles as I did it before in the previous questions. From 8 corners, it will be 1 particle, and from 6 face centers, each face center will provide 1/2. From 6 face center, it will be 3 particles. That gives the total of 4 particles. 1 plus 3, that will be giving the total of 4 particles. Thereby, I come to the ratio of the particles of M and X. From the calculation, I can get particles M as 4 and particles of X as 4. Thereby, I elucidate the formula as M4 X4, which can very well be simplified into Mx. That makes me to go for the option A. Formula of the compound is Mx. That's how the calculations. See how simple it works out. So many types you can have here. Simply calculating the number of particles, that is one type, or converting them into the formula is another type. Varieties of the options there in the questions also. So, my dear students, we have seen some of the questions or some of the numerical examples that can be expected out of this topic. Nevertheless, it doesn't mean that only these questions which we have covered, only these types will appear in the examination. There will be a lot more in the anticipation, because in the stipulated time, we are trying our best to make these things familiar and to keep the students at home with the requirements of the examination. The questions from solids in general and physical chemistry in particular, you can expect of 3 types. Either they are the theoretically based questions, or the recall type questions, or numerically oriented questions, wherein we have to adjust our time and we have to adjust our mindset according to these questions. And one more thing, as far as possible, go for the calculations mentally and logically, and for most of the times in chemistry, you have the options with much and more differences. Approximate answers will do. Never go for the precise answers unless they are required. And keep on trying and have an approach in correct direction, and you will be getting what you are aspiring for. Thank you.